When we develop a REST API, we create endpoints using methods such as get, post, or delete. And for example, people using our API expect that making a GET request lists data instead of deleting it. And it's our job to make sure the API is easy to understand both to our teammates and people using it. A lot of HTTP methods are straightforward. However, modifying existing data can be done either for the put or the patch method. In this video, we implement both of them and outline their differences. In our database, we have a very simple model of an article. It has a few properties such as ID, title, contents, and description. And an important thing is that description is optional. Let's take a look at the API. When we do a put request, we can modify any of the properties. Let's try changing something. Let's say content. Okay, there's one problem. To make a put request and modify a particular article, we need to add its ID in the URL. Just like that. And now, when we click send, we see that the article was modified. And if you remember, the description property is optional. Let's see what happens if we omit it from the body of our request. When we don't provide the description, it's removed, which is very, very important. So when we make a put request, our API expects that we provide all of the properties that we want our article to have. Basically, we replace the existing article with the data provided in the body of the request that we are making. Once again, let me modify the content and let me bring the description back. How do we implement such a handler? Let's start by creating a new method in our article service. The first argument is the ID of the article. The second argument is the request body. And to do that, let's create a new class. It's called DTO, meaning data transfer object, because it transfers the data from the request to the service and it transfers the data across our application. So what properties can we have when we are replacing our article? Definitely the title, which is a string, content, and description, which is optional. So far, so good. Let's use it in our article service. To modify the data of a particular entity in the database, we need to use the update method. It accepts a single object with the where property. We use it to indicate to Prisma which entity we want to modify, and in this particular Example, we want to modify an entity with a particular ID and the data property. Okay? We got it. The second thing to do is to implement a method in our controller. For starters, we need to import the put decorator from NestJS and create a handler. Since we expect the user to provide the ID of an article in the URL, we need to add the ID into the arguments of the put decorator. Let me do that. Okay, and our method also accepts a few arguments. The first one is the parameter from the URL, and an important thing to understand is that when we make a put request, or any request for that matter, when we provide some arguments in the URL, they are always interpreted as strings first. So this is not a number yet. It is a string with the number 1. And to deal with that, we can create a class such as this one using the class transformer library that transforms our string value into a number. Thanks to that, here it is a number and not a string. Okay. The second argument is the body from the request. To work with it, we need the body decorator from NestJS, and we need to use the appropriate DTO, data transfer object, that we've created not long ago. Okay? Let's use the method that we've created in our article service. And let's run our API. And let's see if it matches the behavior that we've seen before. Okay, let me modify the content. Yes, you can see that the content was indeed modified. Okay, let's see what happens when we do not provide the description. And here we have a slight issue. You can see that the description property, even though we did not provide it, wasn't removed from the database. So let's take a step back and see why that is. Let's go to the article service, and when we provide the data for the update method in Prisma, it only modifies the properties that we provided explicitly. So how can we force Prisma to remove the properties that were not provided? One way of doing so would be something like that. When we provide the description explicitly as null if it wasn't provided by the user. A better solution, more elegant solution would be to go to our data transfer object and provide it with a default value with null. Let's see if that solves our problem. Yeah, you can see that the problem was solved, and we've managed to implement a fully functional put method. Let's dig a little deeper and cover some of the edge cases that you might encounter. First one that is kind of important is what happens if the user changes the ID of the entity here, you can see that it was actually successfully modified, which you might not want. So to deal with that, for starters, let's change it back. Okay. And we can go to our article service and explicitly set ID to undefined, meaning that we do not want to change the ID even if the user changes the ID that the article has. So with that, let me restart the application and let's see if it helped. Let me modify the ID and you can see that it has no effect. Great, this is just what we wanted. There is a second issue with our API. With puts, if we omit one of the properties like that, it means that we want to remove it. And the description is optional, so it is perfectly fine. But what happens if we remove the contents or the title? Well, we need to prevent the user from sending a put request with the content or the title missing. And to do that, we can add validation to our DTO. To do that, we need the class validator library. It has a few useful decorators, such as isString and isNotEmpty. By doing that, we say that the title in our article needs to be a string that is not an empty string. Like that. We don't want that. Okay, the same goes for the content and a similar thing for description. Although, if we use the isString and isNotEmpty decorators, we state that the content and title are required, but the description is not. So to deal with that, we need an additional decorator. In this case, we can use isOptional, which tells the class validator that if the user does not provide the description, it's perfectly fine. Let's restart our API and see if it helped. Let me remove the contents and the title and see what happens. Great, we've responded with 400 bad requests, which means that our API did not accept the data that the user sent. It says the title should not be empty and it must be a string, and same for the content. It shouldn't be empty and it also must be a string. It also covers cases such as when the user provides a number instead of a string, like that. And you can see that we do not try to put this number into the database, which would result in an error. We are getting close to a perfectly working API. There's just one last edge case that we need to cover. When we make a GET request to list all of our articles, you can see that we have one article with the ID of 1. But what happens if we try to modify an article with a different ID? Like that. You can see that there is an internal server error, which means that something happened that our API does not know how to react to in a better way that the user would understand. We can see that the API responded with internal server error, which means that the server was not able to respond with an error message better suited for this case and an error message that the user would understand. So let's improve this error message. Okay, this error happens because the records was not found. And yeah, we do not have an article with an ID of 2. So let's fix it. To do that, let's wrap our update method call in a try-catch block. And don't forget the await keyword here, because it's important for error handling. If something happens when we call the update method, Prisma can throw a known request error. Let's check if the error that was thrown is indeed the client known request error. To do that, we need to import Prisma and check if the error is Prisma client known request error. Because if it is, it has an additional property called code. And code is a string that tells us exactly what happens. In our case, it is P2025, which means that the record does not exist. And if that is the case, let's throw not found exception. And if it isn't the case, let's throw the error like that. Okay, let me restart the API and see if it helped. Yeah, you can see that the status code is not 404, not found, which tells the user exactly what happened. There's one little improvement that we could do, because it is kind of difficult to remember the string P2025. A way in which we could improve that is to create an enum with values like that. So we no longer need to remember P2025 every time we want to catch an error saying that the record does not exist. Instead, we can use our enum here, which solves the problem. Let's see if it still works just fine. Yeah, you can see that the error message is not found and the status is 404. Okay, so we've managed to successfully create a put handler. To sum it up, the put handler replaces the whole article with new data. So not providing any of the properties means that we want to remove them. Like that. I didn't provide the description, so it is null. But the content and title are not optional. So trying to remove them should result in an error with the bad request status code. Great job on following the video so far. Now let's take a look at the patch method. Let me copy the URL because that does not differ in any way, and body too. Okay, so with the patch method, we also can modify our article. There are, however, a few very important differences. For starters, let's try to modify the contents in a very regular way. Yeah, okay, we can see that it works. Okay, so what happens if I remove the description? you can see that it was not removed from our article. Because of that, we can also remove the content from our body or the title, and it works fine. Because the crucial thing about the patch method is that when we use it, we provide a set of instructions on how to modify the article. And to do that, we don't need to provide all of the properties. You can provide just one of them, and it will be updated. Another case that's very important is removing one of the properties. So we know that just simply omitting it will not remove it. So to do that, we need to explicitly provide null. And you can see that the description was successfully removed. What are some of the benefits of the patch method? Well, I think the most important one is that the user does not need to remember all of the properties. So for example, if someone is making a put request and they don't know that there is a description and they make a put request, it is removed from the article. Which means the user could remove the description by accident. And this is something that would not happen with a patch method, because to remove something with patch, we need to explicitly provide null, which makes it safer, I believe. Okay, let's see how we could implement a patch method. Let's start by making a new method in our article service. The first argument is the number, and the second one is a data transfer object. Let's create a new one. It has a title, which is optional. It has content, which is also optional. And the same goes for the description, which is either a string or null. We need to start by calling the update method from Prisma. To modify the article with a particular ID and with our data. And once again, I am not allowing the users to modify the ID. Okay, let's now create a method in our controller and actually use the update article method. To do that, we need to use the patch decorator from NestJS and use it in a very similar way. The first argument contains the ID, and the second one, the body of the request. Okay, let's start our API and see if it works as expected. Let's try to modify the content. Yeah, it works. Let's try providing a description. Yeah, you can see that it works fine. Let's try removing it. Yes, that's great. Okay, let's try providing just the content, for example. Yeah, you can see that it was modified just fine. There is one case that we need to cover now. So what would happen if the user would provide something like that? Yeah, you can see that it is an internal server error because we are not validating the incoming data yet. To do that, we need to add validation to our update article data transfer object. The first one would be very similar to the one that we've had before, which is string and is not empty. And the same thing goes for the content and the description. There is one thing to remember, that all of those properties are optional now. So what we need to do is we need to tell the class validator that they are not required. And if you remember, when we did the put method, we used the isOptional decorator. Let's try using it right now. And see how it works. Yeah, it says the description needs to be a string. Let's try to provide a valid description. Yeah, works fine. Okay, so let's try not providing the content. Yeah, you can see it is fine, but if we provide a content that is, let's say, a number, it should complain. Very well. Okay. We can also provide null as the description. But there's one significant edge case that we should cover. Let's say we provide null for content. Yeah, you can see the internal server error again. It is because the isOptional decorator allows both undefined and null. But we don't want to allow null for content and title. Because of that, we need to use a little bit more complicated decorator. Instead of isOptional, we use validate if, which means that we want to validate the title, checking if it is a string and it is not empty, only if it is not undefined. Basically, it means that we allow title and content to be undefined. What we could do is to go a bit deeper and make this code a bit more readable. And to do that, we can create our own decorator. Like that, which uses the validate if decorator under the hood. And it looks clean and simple. If we want to be a bit more explicit, instead of using the isOptional decorator, we can use can be undefined and can be null decorator. which is very similar to can be undefined, but checks if value is null. Let's see if it solved all of our issues. Yeah, you can see that the content should not be empty and it must be a string. So we are not accepting null values as the content. We are accepting a string. But for the description, we are accepting null. Yeah, and let's try removing the description. The last case that we need to handle is with the IDs in the URL. So what happens if we provide an ID that does not exist in our database? And this is exactly the same case as we've had with puts. To do that, let's surround our update method call with the try catch block. Let's check if the error is records does not exist, add the await keyword and restart our application. Okay, now let's try using an ID that does not exist. Yeah, great! We have 404 not found, which is exactly what we wanted. So summing it up, when we make a put request, we need to add all of the properties that we want to have in our entity, which means that if we omit one of them, we will remove them, which is the crucial thing about the put request. The patch request is different because we can provide just the properties that we want to modify. And if we omit one of the properties, it does not mean that we want to remove them. It just means that we don't want to update them in any way. And to remove them, we need to explicitly provide null. Just like that. Thanks for following the video so far. In the description below, you can find the link to the GitHub repository if you want to look for the code yourself. And stay tuned for more NestJS related content.